everybody, and thank you for joining us today. My name is Leah Hammond, and I am the project manager of Hayman Engineering, as well as the transportation engineer. I am joined here today by Alex Ketter, our structural engineer, as well as Jack Larson, our environmental engineer. We are excited to share with you our progress report on the Amazon industrial site in Elkhart County. Starting off with transportation, just to recap, my scope of work included the extension of County Road 4, extending between County Road 17 and County Road 19, as well as an intersection, a signalized intersection where County Road 4 extension meets with the Indiana Toll Road, and a stop-controlled intersection where the County Road 4 extension meets with County Road 19, as well as providing access to the academic building that our structural engineer has been designing, and designing a parking lot for the academic building as well. Design controls used for this were the Indiana Design Manual. As you can see on the right side of the screen, all of the horizontal and vertical design controls were taken from the Indiana Design Manual figure 53-8. This was used for my vertical and horizontal alignment, and then for my intersections, the WB67 Indiana Design Vehicle was used for my turning radiuses, and for my parking lots, a WB40 was used for a radius of 45 to be more practical for the expected use of the parking lot. So for my cross-section here, it was the layer depth of the pavement was determined using equivalent single-axle loads for a structural number between 3 and 4. It was found that an aggregate depth of 6 inches, a base depth of 3 inches, an intermediate depth of 3 inches, and a surface depth of 1.5 inches provided a more than sufficient structural number for this project, and on the shoulders, an aggregate depth of 7 inches and a surface asphalt depth of 4 inches provided a sufficient structural number for this project. And then this is a typical section for the alignment of the County Road 4 extension. Moving on, this is the alignment chosen from phase 1 of the project. A vertical profile was also created for this, but is not pictured. So moving on to my signalized intersection, the turning lane configurations were taken from the scope, and the turning radius was again 125 feet for the Indiana Design Vehicle, the WB67. And then the stop-controlled intersection, once again, the turning radius was 125 feet. And then all of these intersections, the auxiliary lanes, have an adequate storage for the daily average, or the daily average vehicle volume. And then County Road 19 was not adjusted due to it being outside of the scope. So my parking lot design, since this is an academic building, this was a challenge because I had to focus on limiting vehicles and buses interactions, because pickups and drop-off times can get very hectic at schools. So the parking lot to the west of the building is meant for pickup and drop-off for parents, and it has enough spaces. The amount of spaces was determined using the Elkhart County regulations, which is based on the amount of occupancy in the school, and then the amount of ADA spaces is determined using the American with Disabilities Act. On the right side is the school bus and staff parking lot. So the school buses are meant to park in those spaces as they are waiting for students to come out of the building, and then it is also a one-way design, which limits the amount of conflict in the parking lots. Future work for this project is creating a preliminary drainage plan, because I have no water resources engineer on my team, so I have to determine where the runoff from my road will go. And then I will continue to develop the intersections and the parking lot for adequate movement on my cost estimate using the NDOT unit price summary. I will now turn it over to the structural engineer.
Thank you, Leah. Just going over a quick little recap of our structural scope. I was made to do a academic building. This is a 2-story academic building. We'll have an auditorium that seats up to 240 people, classrooms, laboratories, offices, restrooms, anything you would find in your typical school building. This will all be done in compliance with codes such as ASC 7-16, international building codes, and anything the Elkhart County regulations want us to follow. And then this will all end up choosing our one design alternative. So the work completed so far, we've done a site analysis, just still kind of recapping that, and now we're moving on to the load determination. This is calculating our live loads and dead loads to decide what material we were going to use and what size of material. We ended up choosing steel, so this is kind of deciding what steel beams, columns, and girders. We have floor plans for our first and second floor, material selection research, kind of going back to that load determination, and then our beam collar and girder layouts. So going into some of those loads, we're going to have to worry about snow because we're in northwest Indiana. So we got our ground snow load, which is that 30 PSF up at the top, and then we found that through using our ASC hazard tool. But that's the ground snow load. We need our roof snow load, and this is a flat roof, so we're using that equation, and that uses factors such as exposure, thermal, and importance factor. These are kind of based off the geography of where it is, how much snow we're going to get, and so forth. We also need to worry about wind load. So this is just an equation. These are all kind of preliminary and can change, but kind of the same idea. It's based on where, what's around the building for wind, because if you have buildings around, it's going to deflect some of the wind, but we're in like a rural area, and there's not many buildings around it, so it's going to be taking on most of the wind all on its own. Moving on to those, so we just have our gravity loads. These are some of the dead and live loads that were used for the roof and floor, just to calculate our LFRD calculations. And then on the bottom, you can see our wind pressure. That was just that one calculation, just showing which factors I decided to use. Those were all done from tables. And then our roof and floor, these are all the exterior and interior beams and girders. And then at the bottom, we have our columns. These were all done with calculations of our tributary area from the widths and using all the loads. These are all hand calculations. We're still working on plugging them into RESA. That will give us different things, I'm assuming, or hopefully it'll stay the same, but these are subject to change. And then just going back to refresh, this is our floor plans, so just relatively showing you where the classrooms, labs, offices, and everything will be. Just an elevation plan, very preliminary. There will be more, just a side view to show you kind of what we're factoring right now. At the top is just gravity loads and then wind loads for lateral. And then, again, just preliminary designs. These will be developed more, and there will be more of them, especially with connection and details. First story is on the right, and then the second story, where the roof is on your left. The auditorium is a double height. So we're working on right now truss designs for those. Those aren't just going to be beams or girders across. This is so we don't have columns running down through the middle. We don't want to obstruct any views. And then moving on to future work, that truss design, like I just told you, we were working on that right now. Then will be RESA, which is our 3D modeling service. Then obviously, when we plug it into RESA, we're going to check everything as we add loads. We want to make sure everything works, and that we'll be also adding bracing if needed. I'm assuming it will, but that'll be done then. And then foundation designs, base plate, connection details, everything that will be in construction drawings and so forth. Now we'll be passing on to our environmental.
Thank you, Alex. So to recap, the project scope of the environmental side of this project is designing water treatment plants to supply 1 million gallons of water per day to the surrounding area. Through last semester, I went through various alternatives and I decided on a groundwater treatment plant for the sake of convenience and lack of pollutants that would be found in the groundwater. As seen here, just a recap of the treatment train. There would be sand filtration, activated carbon, disinfection, water storage and distribution, as well as I designed a fire safety conditions in the case of emergencies. Here's a basic layout of the treatment plants. Working with a 200,000 square foot area, I plan to place the surrounding buildings and treatment processes around the plant. So you can see with the red circles being fire hydrants around the perimeter that I'll be going into more later. Water storage being held in the center. Generators off into the corner, as well as chemical storage, the treatment buildings, and the intake pump. Starting off with the groundwater pump, it was estimated that the static water level below ground is about 20 feet down. An intake pipe will be extended approximately 80 feet below the surface with a total well depth of approximately 100 feet. The minimum pump capacity was designed to be 700 gallons per minute to pump water out, with it being 3 pumps set up for the site, 2 for active use and then 1 for redundancy in case one were to malfunction. Next part of the treatment process would be sand filtration. From my calculations, it was determined that the system required 350 square feet of filter surface to handle the 700 gallons per minute flow rates. There are, with the filter medium composed of 7 different layers, such as a 24-inch sand layer with 0.2 grade size, a schmaltz-sack or biological layer to help collect pathogens, with 6 inches of fine gravel and 12 inches of coarse gravel to catch what remains within the water. Next would be an activated carbon tank designed with a 10-foot diameter for the practical implementations. A carbon bed depth of approximately 7 feet to accommodate the required volume that would be going through it, as well as 3 vessels they would be designed or purchased that will be decided in the budget, with 2 actively filtering and 1 on standby. Finally, with the distillation, going in with the flow rate required of 700 gallons per minute, there will be a chlorine dosage applied to the water of about 5 milligrams per liter, with a 30-minute contact time in which the water would be traveling through the baffles of it, collecting any chemicals left over from the activated carbon, and with a sodium hypochlorite disinfectant used. Finally, there is the storage system that was designed last semester, designed to contain approximately 750,000 gallons of water. 3 tanks will be on site, 2 for active use and 1 for redundancy in case of breach in the hull or malfunction. As well, for fire safety, it was determined that it would be due to the size of the plant, it would be about 10,000 gallons per minute flow rate up from the groundwater. We'd be using the same groundwater source as for the drinking water, but this would not be processed. There would be 10 dry fire hydrants installed around the perimeter, dry because of the cold climate we'd be expecting in northern Indiana, so there'd be no water that would be in the primary tank. 6 would be placed around the perimeters, about approximately 600 feet from each other, and 4 near areas of high risk, such as the generators or chemical storage. Future work that would need to be improved upon would be improving upon the CAD drawings, finalizing designs. For the fire safety, I plan to design a rudimentary sprinkler system. I have not designed any sort of building building codes because that is not part of my scope, or building sketch, that's not part of my scope. And I need to organize and update the cost estimates. I'll pass back to Leah.
Thank you for your time today, and I will now open it up to any questions. Yes.
Okay, Jack, I think that you said like distillation, you mean disinfection?
Misspeak, apologies.
Yeah, on the slide in there, so you're not doing any distillation over here.
I guess that was a typo, I think that was a typo for going into it.
Okay, and so stay on that drawing, go back. The well drawing, yep, over here. So what's the 20 feet in their dimension? What is it referring to?
Oh, that's just for scale. It probably would be better to put it above the static water level, but that'll be remedied.
So that's your scale?
Yes.
Okay, in there. And how do you handle fire protection?
For fire pit, well, I'm currently still in the process of setting up the full scope fire safety project. I'd set up fire hydrants around the area in places of high caution. That would definitely need to have water at the ready in case an emergency broke out.
And what standard or guidelines did you use to locate those fire hydrants? I mean, there is a standard about how far apart, because you are using so many, 10 of them around the building.
Yeah.
And so, what guidelines did you use?
I just use standard Indiana fire guide safety guidelines. I believe it was included in my notes for my paper, but I can get you back with the.
Okay. Do you recall what they are? What does it say?
Looking through it, I was mostly just calculating for the proper flow rate proper flow rates for the water in this, because it would need to be higher for the emergency, because you would need the water coming out a lot quicker compared to just the.
And where are you getting the water for fire protection?
The water would be coming from the same source. as the groundwater.
Are you going to be pumping it during the fire, or is it going to be coming from the storage tank?
Originally it was going to be pumped from the groundwater. I would have a separate pump system, but it could also be a good alternative if I were to get it from the water storage, just as a precaution.
And the fire chief will disagree with you, because they either want a dedicated well or storage, and they prefer like towers. So in case there is power outage, they still can use the water from a tower.
Gotcha.
Let's go back to your treatment train, and so you have slow sand filtration.
Yes, correct.
Why did you select, and then you have activated carbon treatment. Why don't you combine the two and use a pressurized filtration tank and minimize the cost and the space?
That was an oversight during my initial planning of the treatment process.
Are you going to change it?
I plan to change it, yes.
Okay. Alex, do you mind I ask you a question?
Sure.
Okay. Well, I didn't see, you put the equation for the snow loading, so
Yes.
what is, I want to just compare to
You wanted to see what the number was?
to Grace's number, because she got like 46 something. What's your number?
20.79 was my,
Where is it?
it's up in the roof, snow load, gravity loads, top left, 20.79 PSF.
Is that a huge difference between sort of?
Well, Grace's, she's also in a different location, so you have to account for different factors. We actually had that conversation yesterday, because we were talking about snow loads, and ours looked off, and I'm like, well, why is it so off? And we used the same equation, she just had different factors, and her starting snow load was 60 PSF, mine was 30.
So, and my next question is, how do you handle lateral loading, the wind loading?
So that's still Not really, I just calculated a wind load. I haven't really plugged in anything to figure out what the lateral loading is gonna be, but, the elevation was just a design of showing kind of where lateral loads would be, but all very preliminary and very subject to change.
Maybe you have listened to that question about if you are to put the
Definitely.
bracing, at least one side will be
Yeah, there'll definitely be some
framing,
bracing.
the other one cross bracing or something like
Yeah.
that.
You actually asked one of my questions.
Okay, I'm like, ask it.
Yeah, thank you. I was actually embarrassed to ask like 5 questions. Well,
No, that's actually a good one, I like it. I think, I keep always calling Grace Angela, so for some reason, Grace missed that, so I think you need to address that.
I just benefited from that. Yes.
Can you show the intersection plan view again of the?
Signalized or the stop and go?
That one.
That one?
You said all the radii are the same? How many radii are the same?
Yeah.
Or the minimum is the same? Because those are not the same. Right? Isn't the radii over here bigger than the radii over here?
Now that I'm looking at it, it does kind of look different,
Yeah.
but they were meant to be the same.
Well, either they're the same or the minimum, and then it's just, okay, because the intersection is not perpendicular,
Yeah,
that would make a difference. So the 2 questions is,
yes.
make sure you figure out what that radii is, or maybe make that intersection perpendicular since you have that opportunity. If the geometry works, it's always better to have a perpendicular intersection than any kind of an angle, just for sight distance.
I will take another look at that, thank you.
And then, let's go forward in the slides. There.
This one?
Yeah. How, this is good work, by the way, but how far apart are the entrance for the buses and the entrance for the drop-off?
Yeah, so that is something that I'm going to be looking into more because I was trying to get them as far away as possible. But what you can't see here, you can sort of see it in my overview of my full alignment, is not too far. On this side is the County Road 19. It was very difficult to try to figure out where I can have buses enter and exit because, mostly for schools, you typically want one-way traffic, especially if you're designing a school that has a lot of people walking in and out. So I will be working on this more to try to get them as far away as possible because you want to have adequate storage length during those busy drop-off and pickup times because people are going to be lining up wherever they can to pick up their kids.
Exactly, that's a good answer. That's always, anytime you drive around, you'll see cars.
I also added more parking spaces than what was necessary because it's typically how it goes in elementary and middle schools, is you need more than you think you do.
Very good, thank you.
Any other questions?
I want this for Jack. Did you get the 1 million gallons per day? Was that something you determined, or was that provided by the client or the school?
That was provided by the client.
Okay.
So if there is no question from student, I have a couple of questions for Alex. So
Yes.
actually, you're on that page. You didn't tell us specifically. You're using like codes such as. So have you asked what codes and actually what version of the codes the jurisdiction adopts? Because these are like, we cannot just simply say International Building Code. We have to refer to the specific version.
ones.
Yeah.
Yes, I can get more in depth with that in my next report, but I guess this was just like a overview. I can definitely get more in depth. I can't bring up exactly right now.
Okay, so my second question is about the minimum live load that you put for the roof. Yeah. So So it says not applicable, so if I recall correctly, even if there is no occupancy, there is a minimum live load. I suppose it's about like 20 PSF or something?
Okay.
Yeah.
In my research that I did, I kind of assumed and didn't see anything of that, but I can definitely do that in the future.
Yeah, I might be mistaken, but check chapter 4.
Will do, yes.
Yeah, for that. And then my third question is that you mentioned the truss in your, where in the layout you need to use the truss?
For the auditorium, so,
If you go, yeah,
yeah, so it'll be, that's like the roof view right there on the left, so those are gonna be trusses across from left to right in that 60-foot.
from left to right, that's 60 foot. Have you checked if you can replace truss with the plate girder?
As of right now, not exactly, I'm still very early in that design. I haven't gotten much into that, so that's
Okay,
fine.
so that might be.
Very much in the future, yes.
And then the last question, you said that you have not decided about the snow and wind load yet, so you have not computed the numbers, right?
The snow load?
Wind load.
Oh, wind load, yeah. That's just a very preliminary, finding those.
So you have not applied to the.
No.
Okay. How about the gravity loads?
The gravity loads are just from there. Those are all apart. I use the gravity loads as my hand calculations to decide what beams, curves, and columns that is planned to be used right now, but probably subject to change.
Okay. And you answered to Professor Ajoba's question that you have not decided about the lateral load resisting system yet.
Yeah.
Okay. Thank you very much.
Any further questions? Thank you.